Today I'm going to be dealing with setting the frame spacing to accept the new hub that we're putting in here. And we're putting in a Sturmey Archer 3-speed SRF3. The overlock nut dimension on this hub is 117 millimeters. That's a direct measurement. That's not taken off of published data. The wheel that came out of here was a freewheel type, 6-speed freewheel. It measures just a hair under 126 millimeters over the lock nut. And the frame is measuring just under 124 millimeters, so it was sprung a little bit with the old wheel in there. So we're going to be compressing the frame to narrow the spacing. We'll be doing what's called cold setting the frame. In other words, permanently changing the spacing to accommodate the new hub, narrowing it down to about 117 millimeters. The tool I'm going to use for this job is a Hosan frame spreader. It works both ways, it both spreads and compresses the frames. And then we want to make sure that the dropouts are properly aligned, and I do that with the Stein dropout tool. And then after we're all done with that, we'll be checking the frame alignment with the frame alignment gauge. Okay, so we want to put the spreading tool on the chain stays somewhere midway between the bottom bracket and the rear dropouts. And as we compress it, chances are it won't set equally, because the drive side is dimpled for chainring accommodation, and chances are that the drive side will actually bend more than the non-drive side. So we'll have to correct for that later. But first we want to set the spacing and align the dropouts. Alright, so I've got my inside caliper set to 117 millimeters. So we're going to start compressing the frame. We're going to have to actually go past that point and allow the frame to spring back and try and get it to stop at or near 117 millimeters. Okay, so we've taken it down to 117, but we haven't taken it to the yield point yet, so if we relax that again, it'll probably spring right back to where it was. So we're going to have to actually compress it well beyond that till we get the chain stays to yield. So we're going to monitor it with a metric scale, and we've taken it down to about 110 millimeters. We'll back it off and see if that's made any progress, and if not, then next time we'll take it down to less than 110. Okay, so by compressing it to 110 millimeters, we didn't make it yield at all. It's still at 123 plus millimeters. So we know that next time we have to take it down beyond that. Maybe we'll take it down to about 105 millimeters and then back it off and see if we've made any progress. Okay, we've taken it down to 105 millimeters. So we'll back it off and see if that's made any progress. And it has. We're now down to about 119, so we're getting very close. Okay, this time I've compressed it down to 102 millimeters. We'll see where that gets us. Okay, we're measuring just about exactly 117 millimeters. So that's about as close as we're going to get. Alright, we've got the dropout alignment tools installed. We need to make sure that they're all settled fully into the dropout. And now the way this works is we visually align them by butting these barrels together, and we align them vertically and horizontally. And from a vertical standpoint, I can see that they're out a little bit of correction is necessary. A little more so from the horizontal point of view. What we want to wind up with is those two barrels perfectly aligned with each other. Now the way we align them is to use the handles of the dropout tools and physically bend the dropouts. And we manipulate them until we get the tools aligned with each other, both vertically and horizontally. And I think we're looking pretty good. It's probably aligned better than it was from the factory. Now we'll just do a recheck on the spacing to make sure that we didn't change that in the meantime. And looks pretty good. Alright, so now we're going to fit the wheel in there and check the frame alignment and adjust if necessary. Looks like a pretty good fit. Okay, now we're going to check the frame alignment with the alignment tool. And we lay that along the head tube and the seat tube and adjust the pointer so that it touches the outside of the non-drive side dropout. Just touches but no more. Make sure we're still contacting the head tube and the seat tube and we're not resting on any lugs. Then we flip it over to the other side and compare the reading. And it is biased to the non-drive side, which is kind of what we expected to happen because of the dimple in the chainstay on this side. So we're going to have to make a little adjustment here. So the way I do frame alignment adjustment is very simple. Always do it with the rear hub installed in the frame, and I lay the end of the axle on a piece of 2x4, lay the head tube on a 2x4 with a rag under it, put a rag on the seat tube, and while wearing a pair of soft-soled shoes, I will actually put my weight right on the seat tube and manipulate it into shape. Now, I don't want to go jumping on this. Just a very slight application of pressure, because we were looking at about 3 millimeters of misalignment, so we only need to move it about 1.5 millimeters. Looks like first time's the charm. We're dead on first time. That doesn't always happen, but it's good when it does.